Alright, in this quest we're going to talk about solving systems of linear equations by using a method called the substitution method. In your previous quest, you guys were solving systems by graphing. So what you were doing was trying to find that point of intersection, and that was your solution to your system. Today, the reason you have to know this substitution method is because sometimes you cannot find the solution just by graphing. So these two examples show you why the graphing method doesn't always work. So in example number 1, if you were to graph these systems, these are the two lines that you would get. So with this graph, those lines are never going to intersect. Without that point of intersection, you can't solve for the system. Alright, so that's one problem you might have. Another problem, when you graph this system of equations, this is what happens. So I don't know if you can see it very well, but what's the issue here? We need a solution, a point of intersections, but on the graph, these two lines don't intersect at a set point here. It's kind of in between 2 points, so it's a little difficult to see. So sometimes there's not a clear point of intersection. So that's why you need this other method. Hopefully I've convinced you well enough that the substitution method will be helpful. So remember, when you substitute, we've talked about substituting things in for x. It means that you're going to replace with something else. So when you're using this substitution method, I'm going to show you that you're going to set up a t-chart, so something like this, and you're going to be replacing one of the variables into another equation. So the substitution method should only be used when you have a variable by itself, and all of the examples that you're going to be given today will have either an x or a y all by itself on one of the equations. Okay? So let's get into some examples on how you're going to solve some systems using the substitution method. So whenever I ask you to use that method, you're going to set up this t-chart. Okay? You're going to put one of the equations on one side and the other equation on the other side. So for this example, I'm going to take x equals 7 here, and I'm going to put y equals negative 2x plus 5 on this side. Okay? So whenever you're solving systems, your final answer is always going to be an ordered pair. So I'm going to write that my final answer should be an x and a y value. So if we look here, this one's really nice because it already is telling me the x value. X is equal to 7. So I don't have to do any work for the x. I can literally just write 7 for the x. So I'm halfway done. Okay? Your job is to figure out what the y is equal to. And how we're going to do that is we're going to substitute 7 in for the x. Okay? Since x is equal to 7, if I place 7 in for the x, I should be able to solve for y. So I'm going to rewrite my equation using this value. So I'm going to start by writing it over. So y equals negative 2. And instead of writing x, I'm going to substitute that 7 and then add 5. Okay, so we're going to do the math. We're going to do negative 2 times 7 gives us negative 14 plus 5, and that would give me a negative 9. So now you have a y value that you can place in your solution. Okay, so a little different than graphing, but whenever you're solving those systems, you're going to have an ordered pair. So go ahead and try example 4, set up your t-chart and solve for your ordered pair. I'm going to show you one of these examples down here, and you guys are going to try the next one on your own. So to solve this system, you're going to set up that t-chart. So on this side, I'm going to write this equation, y equals 3x. And I'm going to write my second equation over here, 9x minus 2y is equal to negative 18. Alright, so this time it's a little bit different. We don't have one of the variables solved for us, so that's kind of a bummer. We know our solution is going to be an x and a y value, so we have to solve for both. So we have to think, what would be easier to substitute in? Would it be easier to substitute something over here into this equation, or would it be easier to substitute this into this equation? Looks like I know what y is equal to. So I'm going to take, every time I see y, I'm going to substitute 3x into the y. So I'm going to substitute 3x whenever I see that y value, because y is equal to 3x. Okay, so let me show you what I mean. So I'm going to rewrite this equation, 9x minus 2, and instead of writing y, I'm going to write 3x. So times 3x is equal to negative 18. So the reason I do that is because I can't solve this equation with two different variables. Now that I've gotten rid of the y and all I have are x's, it's possible to solve for the x. So I'm going to do some simplifying. So I have 9x minus 6x is equal to negative 18. And now I have two x's on this side, so before I start moving things to the other side, I'm going to combine like terms. So 9x minus 6x would give you 3x, and that equals negative 18. And then do your final calculations. So x is equal to negative 6. Alright, so there's my x value. Took me a little bit, but I got it. And now your job is to finish it off by finding that y value. So if x is equal to negative 6, now I'm going to substitute that in for my x, and that should give me my y. So now I have y equals 3 times, what's my x value? I found that to be negative 6. So now I can solve for y. Y is equal to negative 18. So I have my y value, and I'm done. Okay? So this one, you have to substitute 2 different times because you aren't given one of the values first. Alrighty? So try example 6, answer that in your video, and you're all set.